Okay, this is the answer key for the Chapter 9 review that will be for the test that's on Monday and Tuesday. I would suggest that you work through the review first and then come here to check your answers, or maybe if you get stuck on a problem, but try the problems first on your own and then come here to check or see if you need extra help. So for exercises 1 through 3, it says to use this spinner at the right, and it says, what is the probability written as a fraction in simplest form? So whenever we do probability, it's the number of favorable outcomes divided by the number of total possible outcomes. So the probability of getting C, there's only one C on the spinner, so it's going to be 1 out of, there are 6 sections on the spinner, so it's going to be 1 out of 6. And then that one's already simplified, so we can just move on to number 2. Number 2 says, what's the probability of spinning a vowel? There are only 2 vowels on here, A and E, so there's 2 favorable outcomes, divided by the number of total possible outcomes. Again, there are 6 total possible outcomes. And then this one needs to be simplified, and I can divide the top and bottom by 2. So I'm going to do divided by 2, so 1/3 is the total number of, or is the probability of spinning a vowel. Number 3, what's the probability of not spinning D? There are 1, 2, 3, 4, 5 sections on the spinner that are not D out of 6 total, and that one can't be simplified. Remember that if we talk about rolling D, or spinning D, sorry, and not spinning D, those are complements. Those events are complements because there's only 2 options, D and not D. Or if we said the probability of spinning a vowel or a consonant, those are complements because those are the only 2 options, vowel or consonant, there's no other option. Okay, for 4 through 6, we're going to give the total number of outcomes in each sample space. That's where we're going to use the fundamental counting principle and multiply the number of options together. So for picking a month of the year, there are 12 options, there are 12 months. Times tossing a coin has 2 outcomes, heads or tails. 12 times 2 is going to be 24. So, there are 24 total possible outcomes for number 4. Number 5 says rolling a number cube and tossing a nickel. A number cube is like a dice, but cube specifies that it has 6 sides. And then a nickel, again, our only options are heads or tails, so 6 times 2 is going to be 12 total possible outcomes. 6 says choosing a setting on the washing machine from regular, delicate, or extra dirty. That's only 3 possibilities. Hot, warm, or cold water is 3 possibilities, and then regular rinse or extra rinse is 2 possibilities. So I'm going to do 3 times 3 times 2. 3 times 3 is 9. 9 times 2 is 18. Number 7 says, what is the total number of outcomes for choosing a number 1 through 10 and a day of the week? So there are 10 numbers 1 through 10, and then 7 days in the week. 10 times 7 is 70. So there are 70 possible outcomes. Number 8 says a store is handing out coupons worth 10%, 15%, 20%, or 25% off. Each coupon is equally likely to be handed out. Which of the following models could be used to simulate this situation? So there is a 1 in 4 chance of getting each of these coupons. So whatever we use to simulate needs to also have a 1 in 4 probability. Flipping a coin 4 times has a 50% chance. 4 times means we're giving out coupons to 4 people, so that's not what we want to do. G says spinning a spinner with 4 equal sections. That sounds like it might be right because it has 4 equal chances, or a 1 in 4 chance of each section being landed on, but let's check the other ones just to be sure. H says rolling a number cube labeled 1 through 6. That's a 1 in 6 probability. I says rolling a number cube labeled 1 through 6 4 times. Again, that's a 1 in 6 probability, and that's 4 times would be if we wanted to simulate what the next 4 customers got. So it's going to be G, spinning a spinner with 4 equal sections. Okay, let's go on to the back. Back says 9, what's the probability of tossing tails? And we have to use this information up here. Bailey tossed a coin 10 times. The results were 7 heads and 3 tails. So remember, theoretical is what should happen. Experimental is what actually happened. So this is experimental up here. So when it says the experimental probability of tossing tails, we got tails 3 times out of 10 tosses, and that's already simplified, so I'm going to put 3 out of 10. 10 says, what is the best comparison between the theoretical and experimental probability of tossing heads? So heads, the theoretically we should have gotten heads 5 out of 10 times. Experimentally we got it 7 out of 10 times. So the theoretical is less than the experimental. So that would be G. Number 11 says a bag contains 4 red marbles and 2 white marbles. A marble is selected, kept out of the bag, and then another marble is selected. What is the probability of getting red then white? Since the marble is kept out of the bag, these are going to be dependent events because the probability of the second event depends on what happened in the first event. So the probability of picking a red marble is going to be 4 out of 6 because there are 4 red marbles and 6 marbles total. The probability of picking a white one after that is going to be, there's 2 white, but now there's only 5 marbles in the bag because we took one out during the first event. So it's going to be 4 out of 6 times 2 out of 5. 4 times 2 is 8. 6 times 5 is 30. And I can simplify that by dividing the top and bottom by 2. And I will get 4 out of 15. So that would be C. Number 12 says a permutation of 8 choose 3. That means we're going to do 8 times 7 times 6. We're going to start at 8 and then do 3 numbers and multiply them together. So 8 times 7 times 6 is 336. So that's H. 13 is the same thing, so starting with 10, we're going to choose 4 numbers. 10 times 9 times 8 times 7. 10 times 9 times 8 times 7 is 5,040. 14 is 12. Starting with 12, we're going to pick 3 numbers. 12 times 11 times 10. 1,320, so that would be I. Uh-oh, for 13 I should have put C. Okay, and then we're on the last section, 15. A number cube labeled 1 through 6 is rolled and a letter is selected from the word music. Find each probability. These would be independent events because whatever I get on the number cube does not affect which letter I get from the word music. So the probability of getting a 2 on the number cube is 1 out of 6. Probability of getting an S in music is 1 out of 5. When I multiply those together, I get 1 out of 30. So it's going to be D. Number 6 is the probability of getting a 6 in a consonant. Again, the probability of rolling a 6 is going to be 1 out of 6 because there's 1 6 on a die out of 6 sides total. In a consonant, there are 1, 2, 3 consonants out of 5 letters total. And then I'm going to cross cancel here. So 3 goes in here 1 time, 3 goes in here 2 times. 2 times 1 is 1, 2 times 5 is 10. So that would be F, 1/10. And then the last one, a jar contains 5 marbles, 5 blue marbles, 6 yellow marbles, and 4 green marbles. What is the probability of randomly choosing a yellow marble, not replacing it, and then choosing a blue marble? So this is going to be dependent again because we're not replacing it. So probability of choosing a yellow marble. Yellow is 6 marbles out of 15 total times, we didn't replace it, so now we're going to choose a blue. There are 5 blue, but there's only 14 marbles in the jar because we took one out right here. Then I'm going to cross cancel, so 5 goes in here 1 time, 5 goes in here 3 times, 2 goes in here 3 times, and 2 goes in here 7 times. 3 times 1 is 3, 3 times 7 is 21, and I can divide the top and bottom by 3, and so I get 1 over 7. So that would be C on this one. Make sure, I won't be here on Monday, so make sure if you need help on this, you come in before that or ask another math teacher before school if you need help before the test.